Good morning, everyone. Welcome to my YouTube channel, Zero Like Zone. How are you guys? Let me know in the comment section. So today we are going to discuss about acid properties. Okay, so which is a very important concept, or we can say it's very important properties which are used in relational database management system. Okay, so what is the full form of ACID? Acid. So A stands for atomicity. C is for consistency, I for isolation, and D for durability. So now let's understand one by one. Talking about atomicity. So let me explain you with the help of example. Okay. So I want to transfer money from account A to account B, right? Or you may say, like, let's say if you are transferring money from account A to account B, okay, and due to some technical issue, the technical issue can be the network error or any other issue, and the transaction is fails. Okay. For example, you may say the amount is deducted from account A, but not deposited in account B due to some issue. So, so here, what will happen? The whole transaction will roll back. Okay. So we have to start from source again. So here the failure can be due to the network issue, or sometimes the transaction is rolled back because, like, the basic requirement, right, to transfer a money from one account to another is, right, the account number and the IFSC code should get matched, right? Uh, where we have to transfer the money, that account number and IFSC code should we have to mention correct, right? We have to fill the details properly. So if any of the details is not properly entered, so then transaction fails, or as I said, any network issue. So due to this type of some transaction failures, the whole process or whole operation get reverted, or you may say the rollback. So this nothing but this mechanism is nothing but the atomicity. So what it actually defines, I mean, say how we define atomicity. So atomicity is something but it ensures the series of operation, that is the transaction, right, are either completed successfully. If not completed successfully, okay, due to some failure, no changes will be made. Okay, the database will remain as it is. If the transaction is completed successfully, then the changes will be reflected. If not, the whole database will remain same. No changes will be made. Okay. So this is nothing but atomicity. Okay. Moving forward now, C is for consistency. So again, one example here. While transferring, or you may say if you are withdrawing some amount from a particular bank, right? If you want to withdraw your money from your bank, okay, the withdraw fails. So let's talk about there is a common bank rule, right? That states no account can have a negative balance. Okay, so or there is a withdrawal limit also, right? Okay, so like if you have zero balance in your account, let's say, okay, then if you want to withdraw some money, okay, of course the transaction will get failed because there it will throw a validation, or it will a pop-up will appear, right? That it will say, the system will say that you don't have enough balance, right? So what it's actually, it's maintaining the consistency, right? That, like, you should have the certain amount to withdraw the money, right? So this is nothing but consistency. It maintains the database, or you may say it is maintaining or following the set of rules. So that is nothing but is consistency, right? So what consistency actually says, it ensures that all the data must meet the integrity constraint, or you may say in simple words, to follow the set of rules, or the system follows this set of rules. Like if we talk about technically, I mean with respect to database, it ensures all the foreign key, or you may say the primary key, and other constraint, like you not null, this column or that column should be not null. So it is properly defined in database schema. If these all constraint or these all rules are satisfying, then of course that represents consistency. Okay. I hope you guys are getting. Let me know in the comment section. Moving forward now. I for isolation. So again, let's say there are two users, right? Okay, and they are transferring money. So while transferring money, that the transaction should is occurring simultaneously, right? So it ensures no conflict between two users, and both the users are transferring money, okay, without any conflict, and the transaction is happening successfully. Okay, okay, so that's nothing but the isolation. Like both, like for example, both the users are withdrawing. So to to that particular transactions are happening, okay, one by one simultaneously without any conflict. So that's nothing but the uh, isolation. So what actually isolation says, that transactions are isolated from each other, right? Even though multiple transaction might be occur, right? Both the users, okay, one user can do 3 to 4 transaction at a time, right? And another user can do more transaction, right? So the intermediate steps, that the transactions, of course they are not visible, that are happening internally, but it ensures it's completed successfully, right? It should means internally it ensures that the transactions are happening without any conflict. That's it, nothing. In simple words we can describe like this. So isolation, okay, that do not conflict with each other. So and the transactions are happening successfully, that's nothing but isolation. Moving forward with the D for durability. So again, if you are transferring, if you have done one transaction and that transaction occurred successfully, okay, without any failure, the transaction status is success. Okay, then as soon as the transaction is success, the database is crashed due to some technical issue. The whole transaction from past till date, we can recover, or you may say the changes will be recovered as soon as when we restart the database. Okay, in the daily life we experience now, we are using some application, or if you are performing any transaction, though the transaction occurred successfully, but still we are unable to see the data as soon as we restart any app or any application. So again, the system works properly. So here what happens, the transaction is done, but due to some technical issue, you may say the database is crashed due to some issue. So all the changes from past till date, okay, it will be recovered. So that is nothing but the durability. Okay, so it's nothing but once the transaction is committed, it will persist, right? Even in the event of any system crash. Okay, once it's done, the transaction is done means committed. So there is no chance of any rollback, right? Transaction is done means it's done, completed. So the database ensures that all the changes made by the transaction are permanently returned to disk. That's it. It's nothing about durability. So now, these, as I said, asset properties is a subset and most important part of RDBMS, that is Relational Database Management System. So, where it is used in banking system, okay, as we discussed the four properties, as I explained you with an example of banking system. So, the bank transaction, in each and every transaction, these properties are involved. Okay, so moving forward now, another example is e-commerce platforms we have, right? We have online reservation systems, we have to book a train ticket, we have many reservation systems we have for if you want to book a flight, and healthcare system also. Okay, because these all systems, RDBMS, Relational Database Management System, is involved, right? So again, ultimately, asset property role comes here. Okay, so let's summarize. Atomicity ensures the transaction is completed fully or not at all. If the transaction is not completed successfully or fully, roll back. Simple. Consistency. It ensures that all the database schema, I mean the internal part, is uh, is fully completed or is satisfying, or it is satisfying the whole, it fulfilling the rule constraint, right? Or it fulfills the set of rules. That's it. That is isolation. Ensures all that transactions do not interface with each other, right? As we discussed, that both the users are performing the transaction with no conflict. Okay. Durability ensures that one transaction is committed and it's permanent, right? And as the transaction is committed, or in other words, we can say it's completed. So if any technical failure comes, we can recover the data. That is okay. So why we need asset properties? Okay, the answer is very simple: for data integrity, or you may say the data consistency or data reliability. Okay, simple. Okay, these are all interview questions. Okay, so this is the best answer. Okay, so thank you guys. I hope you understand like what is asset properties. Okay, or you may say the importance of asset properties. Okay, in the next video we'll discuss again some of the topics. Okay, so let me know in the comment section. As I said, feedbacks are always welcome. If you have any doubts, let me know in the comment section. So like, share, and subscribe. So see you guys on the next video. Till then, thank you. Have a nice day.